This is part 3 of our rational function mini lecture, and this has gotten a little bit tougher on us. It's the function x squared minus 3x minus 4, which is a polynomial, actually it's quadratic, and x squared minus 4, which is also quadratic. If you notice, the degrees on both of these are 2. Okay, and so this is definitely a rational function. Now, the first thing we're going to do is we're going to factor the numerator and the denominator. We're going to try to reduce this thing down. So this is how it factors. So this thing right here has no common factor, so it doesn't reduce. So the good news is there's no holes. So if there's no common factors that cancel out, there are no holes. Most of them will not have holes either. It won't have holes, and most of them will not have oblique asymptotes. Most of them will have horizontal asymptotes, vertical asymptotes. Pretty much that's the big theme here anyway. So x-intercepts, as remember, was when we set the numerator equal to 0. So we set x minus 4, x plus 1 equal to 0. So x equals 4 and x equals negative 1. And that's the x-intercepts. So 4, 1, 2, 3, 4, and negative 1. Again, these are x-intercepts. They do cross because they are odd degreed. Odd degree here, odd degree there. They're both odd degreed. And so you have 2 x-intercepts right there. Now the y-intercept, there's only one, is setting the denominator, setting the x is equal to 0. So if you set all the x is equal to 0, I'm going to go back to the original because it's easier to set these x equal to 0. So 0 squared, 3 times 0, 0 squared, they're all 0. You end up with negative 4 over negative 1, a negative 4, which is a positive 1. So the y-intercept is right there. All right, so that is the x-intercepts. And again, like I said in part 2, these are kind of like doorways. The graph goes from one doorway to the other doorway, and it's trying to get through to the next compartment. So now the horizontal asymptote, in this case, is y equals 1. And the reason it's y equals 1 is because the degree on top is 2, the bottom is degree 2, so there's no obliques. Their degree is the same, so you divide the leading coefficients. This is 1, this is 1. So the reason the horizontal asymptote is y equals 1 is not because 2 divided by 2 is 1. It's because 1 divided by 1 is 1. And that's important because if this number was a 3 and this number was a 2, the horizontal asymptote would be 3 halves, not 1. Okay, you don't divide the leading the exponents, you divide the leading coefficients. That's very important. So the horizontal asymptote is y equals 1. Now, the vertical asymptotes is going to be found by setting the denominator equal to 0. So x minus 2 times x plus 2 equals 0. So x equals 2 and x equals negative 2. And these are domain errors. This just tells me these numbers are not allowed. So at negative 2 and positive 2, there are vertical asymptotes. Okay, so those are the domain errors. Now, remember the C. The C stands for crossing the horizontal asymptote. Sometimes you get lucky, and this is one of those times. I want to know, does it cross the horizontal asymptote? Well, this is a horizontal asymptote, and I have a point on the horizontal asymptote. So I've gotten lucky that I've got a point right on the horizontal asymptote. So yeah, it does cross it. It crosses it right there. Now, again, if you're blind, you didn't see that, then what you would do is you'd set the function x squared minus 3x minus 4 over x squared minus 4 equals 1. Set that equal to the horizontal asymptote. Solve for x. When you do that, you get x squared minus 3x minus 4 equal to x squared minus 4. Because x squared minus 4 times 1 is still the same. The x squares cancel, and so do the negative 4's. They cancel, leaving me with negative 3x equals 0. So dividing by negative 3, you get x equals 0. So indeed, x equals 0 right here, and then you put a point on the horizontal asymptote at x equals 0. But it was already there. So we were kind of wasting time when we did that because it was obviously that's where it was at. Now, remember, oblique asymptotes and horizontal asymptotes cannot coexist. It's either going to be one or the other. So now we're ready to trace. We've kind of been tracing all along here. Remember, there are no holes here. So the question is, do we have enough? Well, the answer is yeah, because you're either going to be in this realm or this realm. Well, it's obviously this realm because there's already a point down there. So And remember, you got to get snuggling up to your asymptotes. And remember what I said in part number 2, you ended negative, so you will start positive on the other side. And it looks for a doorway. And it's found one right there. Then it goes to the other side and looks for another doorway, and there it's found one. And it crosses, and it doesn't touch and come back. Besides, if it touched and come back, it would have to cross at the horizontal asymptote again, and it doesn't. So it crosses and snuggles up into negative, so it will start positive. So it's in this realm. See, it cannot be in this realm anyway because it had to have another x-intercept. So these will have to make sense the way they are. So ended negative, starting positive. Could not be over here because it would have to cross at this point somewhere, and there's no x-intercept there. So a lot of people kind of blow off these intercepts. They don't think that's a big deal. They are a big deal because these kind of tells you where you can go in from one compartment to another. If you want to call them realms, you can as well as that. But they're like doorways, and so if you don't have them there, you kind of don't have a starting place. You don't know where to begin and where you can go in from one side to the other side. So those intercepts are really important to find. And but anyway, if you notice, this one does not have an oblique. It does not have holes. Actually, I think I'm going to add a couple more parts. I'm going to add 2 more examples. My next part will have one that has a hole in it. And the next one I'm going to do is have an oblique asymptote, and that's what I'm going to end this lecture with. So I'm going to have 5 parts. I think I initially said I'm going to have 4. I think I'm going to have 5. So, but anyway, that's it on this example.